The fragments below were generated after treating a peptide with trypsin and chymotrypsin, which are proteolytic enzymes that are commonly used to digest peptides into smaller fragments. So we are given the different fragments, and then we are required to determine the original sequence of the peptide. Let us look at what these two proteolytic enzymes do to a peptide. Let us start with trypsin. Whenever you are given trypsin, you are going to look for the following amino acids. You are going to look for lysine, and you are also going to look for arginine. So lysine is right there, and then arginine is there. The next step is that you are going to cut the peptide bond at the carboxy terminal of your lysine and arginine. So you are going to cut that peptide bond, right? So what this is going to do, it is going to generate 3 different fragments for you. So you will be left with methionine, alanine, glutamine, lysine. You are also going to have tryptophan, valine, arginine, and the last one is going to be leucine, tyrosine, excuse me, and then glycine. So these are the 3 different fragments that are going to be generated due to the trypsin. Okay, now let us look at chymotrypsin. With chymotrypsin, you want to look for your aromatic side chains. So you're going to look at your tyrosine, you're going to look at your phenylalanine, you're also going to look at your tryptophan. So I have tryptophan right there, and then I also have tyrosine right there, right? So the next step, it is to cut the peptide bond. Okay, and then I'm also going to have 3 different fragments. So I have methionine, alanine, glutamine, lysine, tryptophan. I also have valine, arginine, leucine, tyrosine, and then the last fragment is just going to be the glycine. Okay, now let us look at this question right here. So we are given methionine, tryptophan, glutamic acid, and then cysteine, arginine. Okay, let's start with this first fragment right here. So we said that chymotrypsin is going to cleave your carboxy terminal of your aromatic compounds, and then trypsin, it is going to cleave lysine as well as arginine. So you can see that to the right of this arginine, you have a bond there, right? So it means that something must have been removed to the right, because when you look at this fragment right here, you can see that to the right of arginine, you have histidine and phenylalanine. So you're basically just going to connect these two. Okay, so maybe we can just label this. So this is due to trypsin, and this is due to trypsin as well. And then tryptophan is an aromatic, so this is due to chymotrypsin. And then phenylalanine is also an aromatic, so this is due to chymotrypsin. Okay, so we said that to the right of your arginine, you're going to have histidine, and then you're going to have phenylalanine, right? Okay, and then now look at this. To the right of phenylalanine, you have what? You have lysine. So after phenylalanine comes what? Comes lysine. So you're going to have lysine attached there. Okay, Then after lysine comes what? Proline. So you're going to have proline. So as you can see, proline stands alone. So there's nothing that is going to come after proline, and then there's nothing that's going to come before methionine, because I can't see methionine anywhere. It is always to the left. Even like with this fragment, you can see it's methionine tryptophan. So it's methionine tryptophan, and then that's it.